Okay, so we're told that this car, right, can average 140 miles on 5 gallons of gasoline. So we're given this ratio really where it's 5 gallons on average we use for every 140 miles that we travel. So you want to think about that right away. I think, oh, if that's the proportion, I could say, oh, if I go 1 gallon, right, then I go 28 miles. All I'm doing there is saying, okay, well, if this is the average rate and it's proportional, linear, right? Well, then what happens? Well, we can scale this ratio down by dividing by 5. And that tells us something important. It tells us what's called a unit rate, right? How many miles we travel for 1 unit. The unit rate is 1 gallon of gas. And once we have that, we can set up our table here where we have G for gas and D for distance. We set up a table. They don't ask us to set up a table, they ask us for an equation, but the table and equation and graph, they're all connected, so I think it's nice to do all three when you can. So here if we have 1 gallon, we go 28 miles. If we have 2 gallons, we go 56 miles, right? 3 gallons, what happens? Well, we go add another 28, so we get 70 and 14, that's 84. And 4 gallons, well, again, we get 112 because we're adding 28. And 5, 28, well, add another 28, and that gives us 140, and so forth. If you think about what's happening here, right, what are we starting at? Well, I know we started here at 1, but remember, when G equals 0, that's really, this is like your X value. When X is 0, that tells you the starting point, right? It gives you the Y value, the output, in this case, the distance. Well, here, 0 gallons takes you 0 miles, right? So that's our first point. Then it jumps up here. 1 is 28 and 2 is 56. And I added 28 each time. That's our slope, right? Where every 1 gallon, our distance goes up by 28. But if we think about that, right, couldn't I have just said, oh, well, if we go 1 mile, 1 times 28 is 28 miles. 2 miles, 2 times 28 is 56. 3 miles, 3 times 20 is 84, and so forth. We could just take our gallons and multiply it by 28 to find out how far it can go. When that happens, when you can just multiply any given input to get the output, right? In this case, multiply x times 28 to get y, which is our formula, incidentally. This is called a proportional linear relationship, right? There's a direct number, a direct scale factor, right? Proportional. A direct scale factor between x and y. That's proportional. Now on a graph, we can set this up really quick, right? This graph, you can make your gas independent and your distance dependent, although you could flip that. It would be a little weird to do that because of the way this graph looks, but you could do that either way. As distance increases, the amount of gas increases as well. So you can reverse it. It wouldn't really impact your graph too much. Anyway, but 0 gallons, 0 distance. With 1 gallon, though, we're already at 28 miles. So if I go up by 10s here, 10, 20, 30, 40, I'm going to label these every other one, 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm going to run over real quick, so I'll stop there. But after 1, 2, 3 gallons, let's stop there. We can plot this. So 1, we have 28 gallons, so about here. 2 is 56, maybe about here. 3 is 84, so about here. And we have this linear relationship. I really could have gotten away with just plotting 2 points. I just wanted to do my best at setting this up. And that's the graph that connects to this table and equation. It's a nice proportional relationship. One thing about a proportional relationship is that if you're given the graph, you need to identify if this line is linear and proportional. You need to have your line cross the origin. If you think about what's happening, if there's any other value for 0, like let's say 0 and 10 or something at a point up here, there's no way you could just multiply your x values to get your y values. Remember, with your y-intercept, x is 0, and 0 times anything should just give you 0. If it's not, there's more to it. Right? In other words, you can't just multiply x by a value to get y. You might have to add or subtract something as well. So That's one thing to look for. If you're asked if this is a direct variation or proportional, try and see if your line crosses your origin. All right, hope this helped.